Welcome to YuvaTeck. So in continuation with the previous videos, let us see the question ID 911. So I request you all to subscribe our channel. Also give your comment on the comment section. So let us see the question. The question is, which one of the following statement is true? Option 1, superposition theorem is not applicable for voltage calculation. Option 2, superposition theorem is not applicable for power calculation. Option 3, superposition theorem is not applicable for bilateral elements. Option 4, superposition theorem is not applicable for passive elements. So the correct answer is option 2, superposition theorem is not applicable for power calculation. So let us see the statement. So before that, here you have to understand that the statement is true. Which is the statement? Given statement is true. Means the option 1, 3 and 4 are false statements. Which means the superposition theorem is applicable for voltage calculation as well as it is applicable for bilateral elements as well as it is applicable for passive elements. So let us see the superposition theorem, what it states. So in a linear bilateral DC network containing more than one energy source, the resultant potential difference across or the current through any element is equal to the algebraic sum of potential differences or currents for that element produced by each source acting alone with all other independent ideal voltage sources replaced by short circuits and all other independent ideal current sources replaced by open circuits. So this is the statement of superposition theorem. Here we can observe that the superposition theorem is applicable for linear bilateral DC network, as well as using the superposition theorem we can find out the resultant potential difference or the current, means that voltage and current can be found, right? How we will see it now with an example. So before that, we should know certain things. The statement first one is a linear network. So linear network means a linear, you see this figure, right? It is one of the characteristics of one linear circuit, right? So linear circuit is one whose parameters are constant, that is they do not change with current or voltage. So if you see this figure, the slope of the line, right, that is nothing but the resistance value, because it is the ratio between the change in voltage to the change in current. So here that resistance value which will not change. So such circuits are called as linear circuits. So the second statement is bilateral element or bilateral circuit. Bilateral circuit. So bilateral circuit is one whose properties are the same in either direction. Example is a transmission line is a bilateral circuit because it can be made to perform its function equally well in either direction. So the simple meaning I'll tell you. So you can see that in this characteristics, you can observe that quadrant 1, the resistance value it is given. So also if the voltage and current direction, if it is changed, right, then also the properties of the circuit it remains same. You can observe it in the diagram in the quadrant 3, right? So a bilateral circuit is one whose properties are same in either direction. So this is what we call it as bilateral circuit. Okay, and The next one, we will see a simple example of superposition theorem, what it states. So now we understood what is a linear circuit and what is a bilateral circuit. And one more word it has been written on the fourth statement, which is nothing but superposition theorem. It is a wrong statement, means superposition theorem is not applicable like that they have given for passive elements. Actually the superposition theorem is applicable for passive elements. So passive elements is nothing but which receives the electrical energy and then either it will convert it into the heat form or it will store in electric field form or the magnetic field form, right? Those elements are called as passive elements. So passive elements that will receive the electrical energy, so it will dissipate in the form of heat, where the resistance, if you take, it will dissipate the energy or it will convert the energy into heat, right? Or what will happen, it will store the energy in electric field or magnetic field form. Electric field form is nothing but capacitance, magnetic field is nothing but inductance. So resistance, inductance, capacitance are passive elements. So the fourth statement in the given statement, it is not true for superposition theorem. Okay, so let us see the example. You can see the first circuit, which consists of the two voltage sources, 50 volt and 10 volt. And then we can have some resistances, 20 ohms, 5 ohms, 5 ohms and 40 ohms. So as per the superposition theorem, what we have to do is, let us assume I need to find out the current flow through this 40 ohms resistance. So if the voltage source is there, if the ideal voltage source is there, you can open circuit it. If the voltage source is there, you can short circuit it, and if the current source is there, you can open circuit it. Again I repeat, if the voltage source is present, you can short circuit it, and if the current source is there, you can open circuit it, and then you can redraw the circuit, right? Means how to redraw means you have to keep only one source. And let us take if three sources are there. In this problem only two sources are there. Let us take if three sources are there, you have to keep only one source. Rest of the sources you have to either open circuit it or short circuit it according to the nature. Means that depends on that voltage or current sources, right? So in this problem we have two sources. So what I'll do is I'll keep one source within the circuit and other source I'll short circuit it. Here it is a voltage source, so I'll short circuit it. So 50 volt source I'll keep it, and I'll find out the current flow through the 40 ohms resistance. So the answer you may obtain it as 0.589 amps. Similarly, if you see the second diagram, I short circuit the 50 volt and I'll keep the 10 volt. So only one energy source is acting here. So at that time the current flow through this 40 ohms resistance is 0.118 amps. So the total current flow through the resistance 40 ohms when the two sources are there, 50 volt and 10 volt both are there. So simply I have to add these two currents, I1 and I2, that is 0.589 plus 0.118, so which is equal to 0.707 amps. So if you want to find out the current, you can independently calculate the current flow through the element, and you can sum it whenever both the sources are acting. Okay, so that is what the statement it says. Thank you. Happy learning.